brought into one central command post for the very first time.
When we first started, it was overwhelming because traditionally, the fleet returning sonarmen that came to the Virginia had a mindset of the way things used to be, where we were in a room separate from everyone. We could set up the sounds that we needed to hear in our room and no one else was distracted by them.
But before sea trials begin, the specialist crew must get familiar with working together. With little alternative, the Navy agrees to invest in building a simulator. Every detail of this high-tech simulator is a functioning replica of the future sub's control room.
This is a very unique trainer that's specifically for the Virginia class.
That's 060 to the right, more course.
For the first time, the crew get their hands on the same controls as the new super subs.
We were confident that the ship was going to act very similar to the trainer as far as motion, but the procedures and everything that we train on over here are identical to the ship. Go back 2/3.
Go back 2/3, right?
Pilot sonar, no longer hold air.
One thing sonar operators on the new sub will have to get used to is working alongside their colleagues. Sonar has always been monitored in separate rooms to avoid noise interference. But sonar operators destined for the Virginia must get used to working in the new shared space of the control room.
Pilot sonar, no longer hold air, escaping from the aft main bow tank.
After initial reservations, the sonar team begin to see the benefits of working with other engineers.
I think overall, in the big picture, it's a benefit. It gives me, as a sonar supervisor, a larger tactical picture of what the boat is doing.
Here in the simulator, operators will get their first experience of a revolutionary innovation. For the very first time, a US submarine is being built without a periscope. Normally, a periscope extends up to the sea's surface. Using a system of mirrors, it allows one person to scan the horizon. But the ultimate eavesdropper needs to be much more aware of her surroundings. Instead of a periscope, she has a mast with multi-sensors and cameras that enable images from all sides. These sensors, known as photonics, are wired to various monitors in the control room. For the first time in submarine history, everyone in the control room monitors surface activity. And because they're all in the same room, communication is much more responsive.
Control, and I'll brief them that we've gained an enemy warship.
While the crew is being put through their paces, construction of this super sub nears its end. The separate hull sections are outfitted with the internal elements they'll house. And then they're pieced together section by section until a full-length submarine finally emerges. By August 2003, the USS Virginia is ready for the water. Against all odds, the alliance companies have done it. They've built an extraordinary new submarine, more technologically advanced than any in the world. It's an amazing achievement. Right now, any celebration could prove to be premature. Unless they get the next and most important phase right, the whole project could become an expensive flop. Virginia must now endure extensive sea trials. The super sub has to prove itself where it really counts, in the ocean. Often in the past, testing new subs has uncovered countless problems. These have proven to be time-consuming and extremely costly. The USS Virginia has been built using revolutionary methods. Time and vast quantities of money have been shaved off the budget. But if this new super sub is to succeed, there can be no slip-ups during trials. It'll knock the whole project off course. The construction of the all-new USS Virginia is at last complete. It's taken 6 years and has cost the Navy billions of dollars to build. But it's still less time and money than its predecessor, the Seawolf. It's a mammoth achievement, but by itself, it's meaningless. The real test lies ahead. If there are errors now, the huge investment could sink to the depths. It could take years to fix any problems that surface and likely put the project beyond the economic sense. It could even spell disaster for the whole submarine division. In the past, problems have been common at this stage, but this project simply can't afford to fail. It's now do or die for the new Virginia class. August 2003. The USS Virginia is finally launched. Over the next several months, they will put the sub through extensive tests, known as alpha trials. This is when things can, and often do, go wrong. Previously, subs would factor in time for repairs, but in this new economic climate, the Navy and the Alliance simply don't have that luxury. The Virginia must ace the test.
Historically, the first ships of a class wind up with significant problems.
As the USS Virginia heads out on her maiden voyage, the captain and crew will begin testing all her major functions. All the sub's technology must be tested. They start with sonar. It is the traditional way a submarine sees, even through murky water. The system is based on transmitting and receiving. The main feature of the system is the sonar sphere, housed in the nose cone. The sphere is lined with hundreds of hydrophones that act as the ears of the sub. They're called passive sensors. Their job is to listen to all sounds coming from outside the sub. A giant baffle protects the sonar sphere from internal noise interference. The sonar sphere also has what's known as active sonar capabilities, which is when the sonar releases noise pulses and gathers a clear picture of the sub's surroundings based on the bounce back of the sound waves. Along with the sphere at the bow, there are 6 side-mounted sonars, 3 on each side. These provide a more complete picture of the submarine's surroundings. There's also sonar that can be released from the back of the sub and towed with a line. This area behind the sub is often referred to as the blind spot and would otherwise be vulnerable to attack. Because the Virginia is built to operate in shallow waters near coastlines, it is likely to encounter minefields set up by enemy forces to keep our Navy ships out of their waters. These mines are typically scattered throughout the water, anchored into position with chains. Because of this danger, the USS Virginia is the first submarine in the fleet to house a chin array, which works in combination with a sail array to provide a better picture of what lies ahead and make it more effective at spotting mines so that they can avoid them or detonate them from a safe distance before running into them. The sonar system passes through the stringent test with flying colors. Another defining characteristic of the Virginia class that makes it highly adapted for these shallow water environments is its precision handling.
Head 1/3.